In this training, we will address one of the most interesting features of the Rivulis hydraulic tool, which is the EDC, every drop counts. With this tool, you can simulate and design a irrigation system with sprinklers or micro sprinklers or foggers or jets. And this tool will help you understand what is the exact uniformity that you should be expecting to have in your field. So let us go directly into the topic. In order to do the uniformity calculation, we need first to select a product that we want to use. We have here some filters which will help us eliminate some of the products that we don't want to use for this application. Let's see, we want to use a sprinkler, a none done by Rivulis 5022 sprinkler. We have the option, the only option to use it upright. This sprinkler is not possible to be used inverted. No swivel options, but many options in terms of nozzles. Let's choose the option with two nozzles, 3.2 millimeter and 1.8 millimeter nozzle. Then we need to choose what is the pressure that we want to apply to the sprinkler, because depending on what pressure we apply, this sprinkler will provide different flow rates, because this is not a pressure compensating product. So for example, if we choose 3 bar, we will see that the flow rate of this particular sprinkler is 900 liters per hour. If we decrease this pressure to 2.5 bar, we will see that the flow rate turns to 820 liters per hour. Only option we have now for risers for this product is 50 centimeter riser, and the range will be 10.5 meters. Now that we have selected our product configuration that we want to use, we can click on Show Graph, and this will show us a detailed graph on what will be the exact application rate on all of the length of the wetting pattern. So here on the x-axis we have the meters. This is the radius of irrigation. So this sprinkler will irrigate up to 10 meters radius. And here on the y-axis we have the millimeters. So we see here that in the first meter of irrigation we will have around 4 millimeters. And then the water applied will start to slowly decrease when the sprinkler wetting pattern is reaching a limit. This graph is useful to understand what our sprinkler can do, but there is also a nice feature here in which we can compare our sprinkler with another sprinkler and see exactly how they differ. So for example, in this case, we are comparing the 5022 SD with the 6025 SD, which is a more larger sprinkler. And we can see here that depending on the radius that we choose, these two sprinklers will deliver different type of water application. Coming back to our every drop counts, as you can see, when we select a sprinkler, the software automatically suggests to us what is the optimum distance between laterals and distance between sprinklers. We can of course play with these values to achieve our desired outcome. If we move below, we see here that the average application rate in this case will be 32.81 millimeters per hour. We see here the distribution uniformity and the coefficient of uniformity, which is quite high, so probably there is a lot of room here to play with the space between sprinklers, because 98% CU is very high. Probably something much lower like 85-90% is also acceptable. And some other interesting feature we see here, we see which is the wettest zone of the field and the driest zone of the field. We see it here. In blue here, this is the area that will receive the most quantity of water. In the corners of this graphic representation, we have the sprinklers, because we set this to 5 meters by 5 meters. So we have here a sprinkler, 5 meters between them, and another sprinkler here with 5 meters between them. So this is a square of 5 by 5 meters. In this square of 5 by 5 meters, this area in the middle here will receive the most quantity of water. And This area will receive 32 millimeters per hour compared to the average of compared to the minimum of 27 and the maximum of 32. And the driest area will be here in this red rectangle. We can play with this size of rectangles, blue and red. So for example, we can check what is the area, what is the 5% area with the highest humidity and the 5% area with the driest humidity. So this is something we can play with. And the software also tells us, calculates automatically how many sprinkler per hectare we will require. Like I was mentioning previously, this uniformity is quite high, so we can actually start to play with these numbers. Let's try 5 by 5 meters and 5 by 5 meters. Uniformity is also quite, let's try 7 meters by 7 meters. Very good uniformity. Still very good uniformity. Other options that we have here that we can play with the layout of the sprinklers in the field. So first, if we put our mouse over this question mark, we will see exactly what is represented in the graphic to the right. So this square here represented with black is what we see on the right, the black square entitled full coverage. Currently in the layout that we have in front of us, the sprinklers are positioned rectangular, but we can play with this setting and try position them triangular. In this case we see here sprinkler, sprinkler, sprinkler in the shape of a triangle. We can position the sprinklers lateral. In this case we have just one line of sprinklers, so we have here a sprinkler and here a sprinkler and 7 meters between them. Or we can test the uniformity of a single sprinkler. So this is one single sprinkler positioned in the middle, and this is the full radius that it will irrigate. The range will be 7 meters, but the range is 10 meters, but only 7 meters will receive enough quantity of water. Moving to the graphic part here on the right, so let's switch back to rectangular. This is a two-dimensional view of the water being applied to the field. We also have a three-dimensional view, which is very intuitive and very easy to understand where our water will go. And we see here with dark green, we have a high quantity of water, so around 16.5 millimeters per hour. And in the lighter green areas, down to 14 millimeters per hour water. This is a very interesting and interactive tool to show to your customers where the water will end up. Moving back to the two-dimensional graphic, we see here a number of options that we can use. We can add numbers to this graphical representation to understand exactly where the water will go. So we have here 15 millimeters per hour, we have 16 millimeters per hour, 17. So this is something that helps us visualize where the water will go. We can add range of the sprinkler. So here we see the range of each of these 4 sprinklers. This is the range of this sprinkler, this is the range of this sprinkler, and so on, and how these ranges overlap. This is something we can see. We can simulate and display also the plants in the field. Let's say that we have plants of 2 by 2 meter and the plant diameter is 1 meter. And here we can also see how the plant will sit relatively to the sprinkler position and the uniformity distribution. But bear in mind that the software does not count in fact that the water will hit these plants and will not pass over the plants. So this is just a graphical representation so that you understand exactly how the plants will be positioned in relation to the sprinklers. Here we have a different way of showing the precipitation, and we can zoom in, of course, to have a clearer view of what's happening. So here we see more than one square, we see 9 squares, but also with the ranges included in them. And that's about it. It's a quite intuitive and easy to use tool to do quick simulation on how your sprinkler will behave in the field and what uniformity you can achieve.